Okay, this is Improper Integrals Day 2. And so I just want to remind you, there are a few questions that we ask ourselves as we prepare to integrate. And that first question is always, is it a basic rule? We always want to start there. And then we want to see if it's not a basic rule, can we simplify it to make it a basic rule? Can we multiply? Can we divide? Can we use Pythagorean theorem? The simplest solution is always the best solution. Then we want to see, can I use partial fractions or long division? Remember, we talked about this in class today. We use long division if the highest exponent at the top and the highest exponent at the bottom are the same, or the one at the top, the one in the numerator, is greater. Can we use U-Substitution? And if we use U-Substitution, will DU be in the original integrand? And we want to use integration by parts last. Remember, the simplest solution is the best solution. So think horses, not zebras. Okay, yesterday we looked at improper integrals that we integrated over points from infinity or negative infinity. Today we're going to look at they're improper because we're integrating over points of discontinuity. So if we look at this example, and once again, this example is in your notes. So if you turn to your notes in your packet, and this is the first problem under Improper Integrals Day 2. Looking at our notes, we can see that this is improper because when x equals 1, the denominator is 0. And we're integrating over a point of discontinuity since we're integrating from 0 to 1. If we were just to take a quick look at what this function looks like, we see that it is at x equals 1, it approaches infinity. So it has an asymptote at x equals 1. So the question is, can we find the area under an infinitely high curve? We can, but we're going to have to use the properties of improper integrals. So we're taking the integral, we're taking the limit as b approaches 1 from the left side. Why do we use the left side? Because we're coming in from 0 to 1. So we're looking at numbers between 0 and 1 to the left of 1. So what we're going to do is we're going to rationalize the numerator. Now I have to tell you, this problem is probably a lot more difficult than any problems that you will see. When we rationalize the numerator, notice that the radical disappears from over the numerator, and now we can write this as the sum of two integrals. This is sort of like the problem that you had in your on the Unit 0 quiz, which was the most missed problem. But we can separate this into two separate integrals. We can only do this because you have a binomial in the numerator. You could not do this if the binomial was only in the denominator. For the second part of this, we're going to do a U-Substitution. On the left, that integral to the left is sine inverse of x. And using a U-Substitution on the right gives us 1/2 u to the negative 1/2. So what we're doing is now we're taking the limit as b approaches 1 from the left. And we're evaluating it between 0 and b. Substituting in for b on the left and 0 on the right. The sine inverse of 1 is pi over 2. The sine inverse of 0 is 0. And that is our final answer. Once again, that integration of that is probably more difficult than anything that you see, so don't fret over that. We say that this integral converges because it approaches a finite number. We get a constant, so we say it converges. Okay, let's do an example 2. Once again, this is from your notes. Now, if you notice this integral, if we were to graph this, this is what this integral looks like. And as we approach 0, it goes towards positive infinity. So this time we know that x equals 0 is a point of discontinuity. So we have to take the limit as b approaches 0 from the right. Once again, we're taking it from the right because we're looking at numbers between 0 and 1. And so those numbers are to the right of 0. So the integral of 1 over x is natural log of x. And we're evaluating that from 1 to b. And the limit as b as 0 approaches infinity is simply infinity. Because if you think about what the natural log looks like, so actually you can write this a couple of ways. If you looked at this as natural log of 1, which is 0, minus infinity. And if you think what that looks like, that would give us negative infinity. And so negative times a negative, that's why it's positive infinity. So we say that this diverges because the limit is infinite. One last problem for this video. Again, we have a point of discontinuity because x equals 1 is a point of discontinuity. Notice that we're evaluating on either side of 1. So in this case, we're going to have to set up 2 limits. We're going to have to look at the limit as b approaches from the left, and then look at the limit as c approaches from the right. Because when we go from 0 to 1, we're coming in from the left. When we go from 1 to 3, we're looking at numbers to the right of 1. So we would integrate that as normal and evaluate from 0 to b and from c to 3. Substituting in. And we're left with 3 plus 3 radical 2. I'm sorry, plus 3 times the cube root of 2. Okay? Now, there's another video where I work problems a little bit more systematically. That's video 2. So take a moment and watch that as well. And then your homework assignment is in the on your calendar. And it's continuing the homework from last night. And we will work on this tomorrow in class. Remember, your quiz is Thursday. Have a good afternoon.